Dear students, good evening. Now we are going to discuss about inverse Z transform by using convolution theorem. Already we discussed the basic ideas of convolution theorem in our regular class. Now mainly we are going to focus on problems. First problem, you just look at this. The first one, find the inverse Z transform of this function z square divided by z minus 4 into z plus 2 by using convolution theorem. Okay, convolution theorem. Okay, okay. So here first I want to recall the definition of convolution. Okay, so here un star vn. So star is the star means that the convolution of two functions. So un and vn are two functions. The convolution of these two functions is defined as summation m equal to 0 to n and um into v in n minus m. Okay. So this is the definition of convolution of two functions on this Z transform. Okay. Okay, so now we are going to use this convolution to find inverse Z transform of this function. Okay, so as I told in the regular class, the convolution of or the inverse Z transform of product of two functions is uh, found by the convolution theorem. Okay, so here I am going to use the convolution theorem to find the inverse transform of this function. Okay, so first we try to write the given function as product of two functions. Okay, so here the inverse transform of this function z square divided by z minus 4 into z plus 2. Okay, so this can be written as inverse Z transform of product of two functions. So here I am going to rewrite the given function as z by z minus 4. This is one function into the another function is z by z plus 2. Okay, so this is another function. Now we have product of two functions. Okay, so to find inverse Z transform of product of two function, first you find the inverse Z transform for each function and take the convolution. Okay, so here you just look at this inverse Z transform of the first function z by z minus 4. Okay, and you apply this convolution. So Z inverse Z transform of z by z plus 2. Okay, okay. So the resultant expression here is 4 power n. Okay, and star and inverse z transform of z by z plus 2 is minus 2 power n. Okay, because already you know that z transform of a power n is equal to z by z minus a. Okay, similarly z transform of minus a whole power n is equal to z by z plus a. Okay, so if you want to find the inverse Z transform of this function, then you can get, if you have minus here, then inverse Z transform of that function will be a power n. If you have plus, then inverse Z transform of this function is minus a power n. Okay, so we use this formula, then you can get this expression for inverse Z transform of this function and this function. Okay, now you try to remove this convolution star by using this definition. Okay, so here first you compare this expression with this one and choose the function um as well as vn minus m. Okay, so if you are comparing this expression with this one, then we can choose that un is equal to 4 power n and vn is equal to minus 2 power n. Okay, once if you know this function, you can write this function um and v n minus m. Okay, so to find this um, okay, you just replace this n by m, so this becomes 4 power m. Similarly, to find this v n minus m, in the place of n, we just replace n. We just replace this n by n minus m. So therefore, this becomes minus 2 power n minus m. Okay, so you know this function um and v n minus m. Okay, so to remove this star, you just write this expression summation. Okay, so m is from 0 to n and um, so um is 4 power m, so 4 power m. Okay, into vn minus m, so vn minus m is minus 2 power n minus m. Okay, so that's it. Now actually here this m only varying from 0 to n. Okay, so therefore this term n minus 2 power m is the constant term. So constant means here this m only varying from 0 to n. So therefore we can take this minus 2 power n commonly outside. Okay, so minus 2 power n. Okay, summation m equal to 0 to n and 4 power m and minus 2 power minus m. Okay, so this expression can be rewritten as minus 2 power n. Okay, so this is minus 2 power n and this is also m and this is also minus m. So therefore, this can be written as summation m equal to 0 to n into 4 by minus 2 whole power m. Okay, because minus 2 power minus m is equal to 1 by minus 2 power m. Okay, and 4 power m minus 2 power m can be written as 4 power m divided by minus 2 power m. This is minus m. Okay, so in the this 4 and minus 2 having this are having this power m, so therefore we can write these things as minus, sorry, 4 by 2 whole power m. Okay, if we cancel this will be equal to minus 2 power m. Okay, so this will be equal to summation m equal to 0 to n minus 2 power m. Okay, so that's it. Okay, now you simplify this or you just expand this summation. Okay, from m equal to 0 to n, so minus 2 power n, and here if you put it m is equal to 0, then this becomes minus 2 power 0, so that will be equal to 1. Okay, next to m is equal to 1 means can get minus 2 power 1. Next, if m is equal to 2, then that will be minus 2 power 2. Next, minus 2 power 3. And so on. This m takes the values up to n. So therefore, the last term will be this one. Okay, minus 2 power m. Sorry, n. So we just rewrite this one. Okay, so this is n. Okay. So here already we know that the formula for this expression. Okay, so you know that 1 plus x square plus and so on plus x power n is equal to 1 minus x power n plus 1 divided by 1 minus x. Okay, so already we have derived this formula in the regular class. Okay, just to recall this formula. And this formula is very important because most of the time we will use this formula to find the inverse Z transform. Okay, so here we have the expression. Okay, so minus 2 power n and 1 plus minus 2 plus minus 2 power 2 plus and so on plus minus 2 power n. Okay, so in the place of x we have minus 2, so therefore the formula will be equal to minus 2 power n into 1 minus minus 2 power n plus 1 divided by 1 minus of minus 2. Okay, so that's it. So if you simplify this, you can get minus 2 power n into 1 minus of minus into minus plus. Actually, I am going to rewrite this expression as minus 2 power n into minus 2, isn't it? Because n plus 1 means we can split this expression as minus 2 power n into minus 2. Okay, so divided by minus of minus plus, so therefore this becomes 3. Okay, so again if you simplify this, you can get minus 2 power n into, okay, or you just bring this 3 here. Okay, and this will be equal to 1 plus 2 times of minus 2 power n. Okay, so this is the inverse Z transform of this function z square divided by z minus 4 into z minus plus 2. Okay, so this is the inverse Z transform. Okay, so you just look at one more problem. Okay, second one, find inverse Z transform of this function z square divided by z minus a whole square. Okay, so here we have this type of expression. Okay, so this is again a simple one. Okay, by using convolution theorem. Okay, so here as we did earlier, first you try to write a product of two function. Okay, so z by z minus a into z by z minus a. Okay, because here we have z minus a whole square, so you can split this function as z by z minus a into z by z minus a. Okay, so if you want to use this convolution, first you take the inverse Z transform for each function. So Z inverse of Z divided by Z minus A. Okay, but here we have to use this convolution star. Okay, so Z inverse of Z by Z minus A. Okay, okay. So now the inverse Z transform of this one is A power n. Similarly, the inverse transform of this function is again a power n only. Okay, if you have this minus, then that will be plus only. So we have a power n. Okay, now we have to remove this star. Okay, so again you compare this expression with this convolution function, convolution of two functions. So u n star v n is equal to summation m equal to 0 to n. Okay, so u m into v n minus m. Okay, so this is our function. Okay, we compare this expression with this, then we can choose that un is equal to a power n and vn is equal to a power n. Okay, so therefore this u m becomes a power m. Similarly, v m v n minus m n minus m. Okay, so that will be equal to a power n minus m. Okay, so we can choose these functions. Okay, u m and v n minus m from this function. Okay, that the resultant functions. Okay, okay, so now this will be equal to summation m equal to 0 to n. Okay, um is a power m into v n minus m is a power n minus m. Okay, so now here this summation having this m from 0 to n. So therefore here m only varying. Okay, so n is constant only. So therefore we can take this a power n commonly outside. So you take this a power n. Okay, summation of a power m into a power minus m will be equal to a power 0, isn't it? Because if you add these powers, you can get a power m minus m, so a power 0. But here m is starts from 0 to n only. Okay, so first you write these things. Okay, so m minus m only. Okay, instead of the 0, you write this one. Okay, so next thing, just look at this. Here we have a power n summation m equal to 0 to n, and here we have a power m minus m. Okay, first you put m is equal to 0. If you put m is equal to 0, then we have a power n into the first term will be a power 0, that will be 1. Okay, next if you put m is equal to 1, again you can get a power 0, so that is also equal to 1. Plus if you put m is equal to 2, again a power 0, so that will be this one. Okay, so up to this, if m is equal to n, then again you can get a power n minus m, that will be 1. Okay, but how many times we are having this one n times, because here it starts from m equal to 0 to n. So therefore the first term will be, when m is equal to 0, we have this term 1, and when m is equal to 1, we have this one. Okay, so the last term will be when m is equal to n. Okay, so therefore here if we count this, then we have n plus 1 terms here. Okay, because from 1 to n we have n terms, from here to here we have n terms, because here m is equal to 1, this is m equal to 2, this one is a resultant expression when m is equal to n. So if we count this one from m is equal to 1 to m is equal to n, here itself we have n terms, this is n terms. Okay, and when m is equal to 0, we have another term. So therefore the total number of terms are n plus 1 terms. Okay, okay, so now if you have 1 plus 1 plus up to 1 n terms, then how do you take these things? Okay, so if you have n plus 1, then this will be equal to n plus 1 only, isn't it? Because 1 plus 2, suppose, sorry, 1 plus 1, here we are adding two ones. Okay, so this will be equal to 2. If you have these three ones, can get 3. Similarly, if you have 4 ones, then this will be equal to 4. So here we have n minus 1 terms. Therefore, sum of n plus 1 terms of 1 is n plus 1 only. You just use this idea. Okay. If you have ones in 5 times, you can get 5. So here we have 1 in the n plus 1 times. So therefore, the sum of this expression will be equal to n plus 1. So this a power n into n plus 1. So this is the inverse Z transform of this Z square divided by Z minus A whole square. Okay, uh, that's it. So these are all problems for the convolution theorem. Okay, okay. So I will give two homework problem. Okay, we just try to solve these things. Okay, in your home. The first one is, these are homeworks. First thing is, find the inverse transform of this z square divided by z minus 1 into z minus 3. Okay, so these are all homework. This is first one. The second one is, find the inverse Z transform of Z square divided by Z 1 by 2 into Z minus 1 by 4. Okay, so that's it. By using convolution theorem. Okay, so that is important. Okay, so now I'm going to discuss one more problem. Okay, which contains only Z in the numerator. Okay, so that is important one. So that's why. Okay, so you just look at that. Find the inverse Z transform of Z by Z minus A into Z minus B. Okay, so that's it. Here we have only single Z in the numerator. Okay, so this is important problem. Okay, because if you have Z square in the numerator, we can split this function as Z by Z minus A into Z by Z minus B. Okay, but here we have only one is Z. Okay, so therefore to find the inverse Z transform, uh, again I'm going to use the convolution theorem as we did earlier. First you write product of two functions. Okay, so Z inverse transform of Z by Z minus A to Z minus B. Okay, so this will be equal to Z inverse of, you just take this Z with one function Z minus A into the next one is just 1 by Z minus B. Okay, and here if you combine or if you take inverse Z transform for each function, then this will be equal to Z inverse of Z by Z minus A. Okay, star Z inverse of 1 by Z minus B. Okay, so that's it. Okay. So here this will be simple one because already you know the formula for this one. But what about this one? So here I want to give one important formula for this inverse transform. Okay, so you just look at that formula. Okay, so before discussing the inverse transform of Z by Z minus A into Z minus B, first I want to give one formula for this expression. Okay, so Z transform of A power n into the unit step function u of n minus 1. Okay, so this one. Okay, so here uh, this will be equal to the transform of A power n to u of n minus 1 will be equal to uh, A by Z minus A by Z minus A. Okay, so first you look at this uh, proof. Okay, so why I want to derive this formula here? If you take inverse Z transform of A by Z minus A, then you can use these expressions. So that's why. Okay, because hereafter we will use this inverse Z transform for the problem. So first I want to give the proof for this one. Okay, already you know the definition for unit step function. Okay, so u of n is equal to, okay, 1 when n is greater than 0. Okay, 0 when n is less than 0. Okay, so this is the definition for unit step function. Okay, similarly if you have u of n minus k, then this will be defined as 1 when n is greater than k, Okay, and 0 when n is less than k. Okay, here these things, then this is uh, defined. Okay, then if you write u of n minus 1, then the unit step function becomes 1 when n is greater than 1. Okay, 0 when n is less than 1. Okay, so here we have this expression. So therefore, we are going to use this function to find the z transform of this one. Okay, so you just look at that. So z transform of this a power n 2 of n minus 1 is equal to the general one is the summation n equal to 0 to infinity a power n u of n minus 1 into z power minus n. So this is the general formula for the z transform. Okay. So suppose if we have un, then we have the form summation n equal to 0 to infinity un into z power minus n. In place of un, we have this a power n into u of n minus 1. Therefore, we can use this one. Okay. But one more thing, this u of n minus 1, the unit step function will be equal to 1 when n is equal to greater than 1. Okay. But here, this is discrete case only. So, the first term, when n is equal to 0, this becomes a power 0 and u of minus 1, something like that. But z power minus 0, whatever it is. But when n is equal to less than 1, you just look at this definition. When n is equal to less than 1, the function value is 0. So therefore, this u n equal to 0 when n is equal to 0. So the first term will be equal to 0. So the summation, so what I want to say here, the summation will starts from n is equal to 1 to infinity is the valid one. Okay, because when n is equal to 0, this term, the function is 0. Its function is 0. So that's why. So the rest of the function will be a power n u of n minus 1 into z power minus n. And this term is equal to 1 because when n is equal to greater, sorry, this is greater than or equal to these things. Okay. So when n is equal to greater than or equal to 1, then this function is 1. So this expression becomes summation n is equal to 1 to infinity a n and z power minus n. Okay. So now you put n is equal to 1, then this becomes a and by z will become. Okay. If n is equal to 2, then a square z square will come. Okay, next n is equal to 3, then a cube by z cube and so on. Okay, so here you take this a by z commonly outside. So sorry, a by z commonly outside. Then this becomes 1 plus a by z plus a by z whole square plus and so on. Yes, up to infinity. This is also important. Okay, so a by z and for this one, already you know the formula. Okay, so 1 plus x square and so on. So that will be equal to 1 minus x whole power minus 1. Okay, so that's it. So a by z into, if you take this LCM, so z minus a divided uh, so z minus a divided by z whole power minus 1. If you rewrite this a by z into z by z minus a, this z will get cancelled. So a by z minus a. Okay, so that's it. So this is the z transform of a power n into unit step function u of n minus 1. Okay, so this will be equal to a by z minus a. Okay, and if z transform of a power n u of n minus 1 is a by z minus a, then inverse z transform of this a by z minus a will be equal to this a power n to u of n minus 1. Okay, So this is the reverse process. Okay. So now I am going to use this idea to find the inverse Z transform of the given function. Okay. So as I told you earlier, the given expression will be inverse Z transform of Z by Z minus A into Z minus B. Okay. So now this can be written as inverse the transform of z by z minus a into z by, sorry, here you just take 1 because in the numerator we have only one z, so z minus b. Okay, so now this can be written as inverse z transform of z by z minus a star, you have to put star, inverse the transform of 1 by z minus b. Okay, so here we can adjust this second function by a scalar value or constant value. Okay, so here I am going to multiply and divide by b. Okay, because already you know the formula for this one only. Okay, inverse the transform of a power a by z minus a is equal to a power n into u of n minus 1. So here, if you have this expression, we can use this one. Okay, so here the numerator, the b is absent. Okay, so we will just multiply and divide by b here. Then this expression becomes 1 by b into z inverse z transform of z by z minus a. Okay, star was the transform of b by z minus b. Okay, okay, because if we cancel this b, you can get this previous expression. That's it. Okay, now 1 by b, the inverse the transform of this one is a power n. Okay, star the inverse transform of this one is b power n to u of n minus 1. Okay, because just now we have proved this result. Okay, so now here 1 by b is a constant, and you choose un is equal to a power n, and bn is equal to b power n into u of n minus 1. Okay, so therefore this um is equal to a power m, and bn minus m is equal to, this is n. Okay, so n minus m is equal to b power n minus m to u of n minus m minus 1. In the place of n, we have to put this also. That's it. Okay. Okay. Now you take this. Okay, and you try to remove the summation. M is equal to 0 to n, and a power m into b power n minus m into u of n minus m minus 1. That's it. Okay, so this is equal to, here b power n, you can take it out because here m only varying from 0 to n. So b power m, n is a constant term. So, they are like constant term. Okay, so therefore we take this b power n, then b power n divided by b into summation m equal to 0 to n. Okay, and a power m to b power minus m to u of n minus m minus 1. Okay, now you try to use the definition of inverse unit step function, because already you know this definition. U of n minus k is equal to 1 when n is greater than k, greater than or equal to k. 0 when n is less than or equal to k. Okay, less than 0. This is n less than or equal to k. Okay. One minute. Yes, this is 0. Then n is less than or equal to k. Okay. Now, the place of k, we have m minus 1, isn't it? Okay. So, therefore, this u of n minus m minus 1. Okay. Then this will be equal to 1 and n is greater than or equal to m minus 1, isn't it? Because here we have to write u of n minus of m plus 1, isn't it? Okay? We have to write like this because we take this minus commonly outside, this becomes this one. Okay. This thing. Now you define it like this. So this will be plus 1. 0 when n is less than or equal to. Okay. So here again we can rewrite this expression as 1. Then n is greater than or equal to. You take this, you bring this 1 to left side, so n minus 1. Okay. And 0, then n is, sorry, m is greater than or equal to n minus 1. Okay. If m is greater than n minus 1, 0. If m is greater than, m is less than, sorry, this is m is less than, you just keep this m and bring this one, so m is smaller value and n minus 1. Okay, so therefore here if we vary this m up to this n minus 1, it will take the 1 value, the rest of the value, this n, this will be 0. Okay, so therefore this expression becomes b power n minus 1 into, okay, first m is equal to 0 means again this will take this value. Okay, because 0 is less than n minus 1, so this will be 1. And m is equal to 0 means a power 0, b power 0 also 1. Okay, plus next if you put m is equal to 1, then this will be a by b. Okay, next m is equal to 2, this will be a by b whole square. Okay, and so on. When m is equal to n minus 1, then this will be a by b whole power n minus 1. When n is equal to greater than or equal to n minus 1, this becomes 0. Okay, so therefore the terms become 0. Okay, so now we have only this expression. So b power n minus 1. Again, this is of the form 1 plus x square up to n minus 1. Okay, if 1 plus x square up to x power n, then this will be equal to 1 minus x power n plus 1 divided by 1 minus x. In the place of n, we have this n minus 1. Therefore, this 1 plus x square plus so on x power n minus 1 will be equal to 1 minus x power n divided by 1 minus x. So, because n minus 1, so that's why. So, 1 minus the place of x, we have a by b. Okay, and n. So, here you put n divided by 1 by a by b. That's it. Okay, we simplify this. This will be the solution of this the term. Okay, so here can be written as b power n minus 1 into here we take the LCM b power n minus a power n divided by b power n, okay, into b minus a whole divided by b, that will be the numerator. Okay, now you simplify this b and minus 1 will get cancelled. So b power n to b power n minus a power n whole divided by this b minus a to b power n. This and this will get cancelled. The final answer will be b power n a power n divided by b minus. Okay. So this is inverse the transform of, okay. So z divided by z minus a into z minus b. Okay, that's it. Okay, so anyway, I stop this session here. Okay, so the last problem is very, very important. Okay, you just go through it and you prepare well for the exam. Okay, so tomorrow we will discuss a few more application problem. Okay, so in this Z transform. Okay, so you just go through all the videos. Thank you so much. I stop this session.